Welcome back. We shall now overview the types of DC motors which are classified according to the method of connecting the field windings. We begin with the series-wound DC motors. The motor is ideally suited for traction applications where it is required to start under heavy load, for example in a locomotive. The series field, which consists of a small number of turns of thick insulated copper wire, is connected in series with the armature. As a result, the field strength is proportional to the armature current, producing a high torque characteristic. Since the back EMF generated in the armature is insufficient to limit the speed, a series motor is not a constant speed machine and will speed up rapidly as the load is removed. Next, we look at the shunt-wound DC motor. This type of motor has a relatively constant speed characteristic and is typically used to drive a fan or conveyor. The shunt field is very different from the series field and consists of a great many turns of fine-gauge insulated copper wire wound on the main poles of the stator. The shunt field winding is connected in parallel with the armature or shunts the armature. The machine is able to maintain a fairly constant speed since an increase in load will result in an increase in the armature current for a given shunt field current. Finally, let's look at the compound wound motor. The compound motor is a combination of the series and shunt motors and combines the best features of both, having a high starting torque with a fairly constant speed characteristic. The field system comprises a series winding and a shunt winding field, which lie next to each other on the main poles. The shunt field, with its many turns of fine wire, is first fitted, followed by the series field. Usually, the motor windings are configured in a cumulative compound long shunt type of connection. This means that the fields combine, and should the load be suddenly removed, the motor will not overspeed. Like the series and shunt motors, the direction of rotation can be changed by swapping the armature connections. To conclude this section, let us remember that when driven by a prime mover, our DC motor becomes a DC generator, whose output characteristics are determined by the configuration of the windings. For example, a series generator will generate a constant current output. A shunt generator will produce a constant voltage output, and a compound generator will generate a constant voltage under varying load conditions. After the break, we will continue with electrical test procedures.